Okay, so I'm going to try and kind of quickly take us through what we did in class to get a little bit of an introduction to Excel and take a look at doing at least some of the data analysis that we can do for lab number 1, where we did a close look at trying to measure the weights of different note cards, sets of note cards, to predict how much a new pack of 100 note cards would weigh. So, I'm going to recreate a lot of what we saw in class. This will be a little bit different than the older video. I will use the video or the data from the older video, but we're going to make slightly different stuff for what we want to take a look at this time around. So the first thing that I normally do when I'm working with Excel is I will actually keep this top row here actually clear so I can put titles in. We have row 1, row 2, row 3. We have column A, B, and C. So each one of these little cells, these rectangles that we can put stuff in, they have an address. This guy is A1, you can see here. This is B1 for B and 1, C1, D2, E6. So I'm in column E, row 6. And that way we can keep track of exactly which things are where. But row 1 I usually keep for titles or headers. So I need a listing of how many trials I had. I've got 1, 2, 3. Now I had 9 trials, and I could go through and I could type in 1 and 2 and 3 all the way down to 9. But why would I do that when there's a needlessly complicated way to do this? So what I want to do for each one of these, I want it to be one more than the one before it. So we're going to start off and we're actually going to do a little bit of math right out of the gate. Now one of the things that I'm going to point out is in Excel, you'll notice trial is on the left-hand side and 1, 2, and 3 are on the right-hand side. That's a subtle little message that Excel tells you that when it's on the left, it says, hey, there are some words and letters in here. I'm limited in what type of math I can do to it. If it's on the right-hand side, it's sending you a message that says, hey, I recognize this as a number and I can do a bunch of math on it. So these guys are on the right-hand side so I can do math. For each of these cells, I want it to be one more than the one before it. So what I'm going to do is I'm going to select A3, which is 2 here. I'm going to go up to the formula bar and I can left-click in there. And I hit backspace, I can eliminate what's there. And I want it to do some math, so the first thing that I hit is an equals sign. Equals tells Excel, hey, I want you to go and do some math for me. And what I want is I want it to take the number above it, so I'm going to bring my mouse over and I'm actually going to click on the cell directly above it. And you'll see that it outlines it with a little dotted line that's kind of moving around, and it says A2, the address of that cell. And then I'm going to take that and I'm going to put plus 1. And now I've got it, it says 2, just like it did before. But it doesn't say 2 in there anymore, it says A2 plus 1. The nice thing about this is I could always go back in and maybe instead of 1, that's 10. Now when I do that, that automatically updates to 11. Unfortunately, with it being a trial, it's definitely still just 1. Now, like I said, I could type in 2, 3, 4, I could go all the way down, or now what I can do, now that I've taught it the equation that I want, where it's just going to add 1 to the one above it, I'm going to drag this and fill it in. Now you'll notice in the cell, there's a little square down here in the bottom right, and then if I hover over it, my crosshair changes. I'm going to hover over it, left click and hold that, and then I'm going to drag it down, and it will automatically expand that to put the equation all the way down. So you can see here, if I click at one in random here, it's taking the cell above it, adding 1 to it, and that's how it gets that number. Now, the reason why this can be very useful, because it's needlessly complicated, I could have easily just written in 2, 3, 4, up through 9 in the same amount of time that it took me to do that. But what if I had 100 data points? Now, by doing it this way, I can just drag down and I can get it to fill in the entire list for me without having to sit here and type all of those out manually. That's where that needlessly complicated approach might actually become much more useful and become far less complicated than doing it the other way. What I'm going to do is I selected the first one, I'm holding down Shift, and I select the final one. That has me highlight everything in between, and I hit the delete key to get rid of it, because I don't need those. For this one, I'm going to put in 9 data points, and then depending on your data that you got from your group, you should have, if you had 3 people in your group, then you'd have 9 points of data. If you had 4, then you'd have 12, and if you had 5, you'd have 15, and so forth. Because I told you all, at least in general physics, to collect 3 points of data for each one by yourself, and then exchange those with your groups. So I'm going to put along the top 1 card, parentheses, grams, 10 cards, parentheses, grams, and 20 cards, parentheses, grams. Now the final thing that I need is my tare value, which we talked about in class, and I'll mention once we actually get there. Now what I'm going to do is I'm going to hopefully quickly put in the data. Oops, that's supposed to be 1.78. So these are the data points I had for 1 card. Now this is data from last year, so this may be slightly different from what I've seen than what we're getting this year. So be certain to use your own data. Come speak to me if you do not have data from yourself or your groups. We'll see what we need to do about getting you some data. And on the 20 cards, the data that I had was actually incomplete. I only have 6 data points, but that's fine. We're going to run with that and see what we end up with. Finally, my tare value. This is from me manually zeroing my scale. So my scale wasn't perfectly balanced when I had it sitting there with nothing on it. I had to set it to 0.53 for it to be level. So basically, when there was nothing on it, it thought that whatever it had on there was half a gram or so, 0.5, almost 0.53. So every measurement that I've taken, the scale has a systematic error, an error that it's introducing every time it takes a measurement, where it thinks everything is half a gram too heavy. Okay? This section here is my raw data, and that's what I would put into my lab report in the data section. Now, also up here, you'll see it's kind of cutting off my grams over here. I'm going to come in between these two, and I'm going to drag this over so I can space it out so that I can see my titles pretty clearly. Now, I'm going to leave a space, and I'm going to come over here where I'm going to start adjusting my data. I'm going to fix it. I'm going to start doing math on it. This was my raw data over here, and now I'm actually going to start doing analysis on it. And so I've got 1 card, 10 cards, and 20 cards. And what I want to do is the first thing is each one of these data points, everything that I've measured, because the scale was a little bit off, it thinks that it is half a gram too heavy. So what I'm going to do is I'm going to come in, I'm going to hit equals, so it can do the math for me. I'm going to select my first data point, and I need to subtract off that value that the scale kept adding on to them. So I'm going to hit the minus sign and select my tare value. I hit enter, and there it is. 1.12, which is 0.53 less than what the scale told me, 1.65. This should be what my OneNote card actually weighed when I weighed it. Okay? So what I'm going to do is, just like I did over here with the trials, I'm going to drag my little square and have it go straight down so that it will do the rest of it for me. Uh-oh, we've got a problem. Take a look at this, 1.81, that says 1.812. 1.73, 1.73, it didn't subtract it off. Okay, let's see what happens. So let's go back up to our first one, make certain it's good. I'm going to click in the formula bar, and when I do that, it actually color codes it. It shows me I'm taking this square, this cell, minus this cell, and that's good. That's what I want. When I look at the next one, oh, my tare values. When I dragged it down, Excel tries to follow me. And so now it's going with an empty cell. Now there are two ways I could solve this. I could put 0.53 all the way down, so that it just reads the same thing that I want for each of those. But there's another way I'm going to show you, and I'll point out why it's useful even in this case in just a moment. I want you to go back up to the first one, click in the formula bar up here, and we're going to hold Shift and press 4 with our cursor in between the minus sign and the capital E. It's going to put a dollar sign there. I'm going to move over and I'm going to put another dollar sign in between the E and the 2. Now this took me a while to actually learn, but this is actually dealing with what's programmed into Excel. When we put those dollar signs there, we're not just giving the cell bling, we're actually sending a message to Excel that tells it this square, this cell right here, this one, the one outlined in a pinkish reddish color, don't move off of that cell. I want you to stay on that cell, always on that one. Now you can move around with the other ones, but anything that I put the dollar signs in, that tells it stay there on that cell. So I'm going to hit that, and I'm going to drag this down, and let's see what happens. Ah, now it's fixed my data. Let's double check it. So when I click on this and I click in the formula, it went down to the next data point, but it's still staying in that one cell. If I go down to one way down here, and I click, came down to that data point, but it's still staying with that one cell. This becomes very useful. Now, like I said, we could have simply typed out 0.53 all the way down, and then we wouldn't have had to bother with that. Except, then I would have had to put it off on the side too, so I could do this. I want it to do the same thing, and then go over and fix these data points too, so all I have to do is select this guy, and drag it to the right. You don't just drag down, you can actually go to the sides as well. In fact, if I had started off with that, I could have filled in the whole square there, just like this. 11.26, that's about half a gram lighter than what the scale told me, 11.79. You can see that I've gone through here and I've actually subtracted off that extra systematic error from every one of my data points. Now over here, these guys, they were empty cells, and so now when I select this, it's got this, which is empty, so it's going to treat it as 0, minus the tare value, and I end up with negative my tare, but these aren't actually data points, so I'm going to delete them because they're not actually telling me anything. Okay, so we're doing pretty good. I'm going to come down beneath this, and I'm going to set it up to actually do something else for me. Now we've got an idea on how we can teach it to do simple addition and simple subtraction and use some of the cells here in Excel. What I'm going to do now is I'm going to start using some of the functions. Now, there'll be a button up here by the formula bar that we've been using up to this point to type things in, to add our dollar signs, among other things. When you click the Insert Function button, F sub X, it's usually right up here next to the formula bar, no matter what your version of Excel is. It'll bring up a box where you can actually type in your function that you want, and it will search for it and give you a list of them, and you can choose the one you want. Now, because of my experience with this, I know that if I do that, my laptop is going to get pretty laggy while I record this video. So what I'm going to do is I'm just going to type it in manually. You can go ahead and play with the function button. Feel free to pause the video and do that. We're going to search for a function called average. So see if you can find that, and it's going to ask you for the numbers that you want to average. You just select those and plug those in, see if you can get the average. Feel free to pause. I'm going to continue now, though. I'm going to type in that I'm looking for the average here, so that I've got this marked. I know exactly what it is. I'm going to do some math in this cell, so I'm going to hit equals. That's how I get Excel to do math. And now I'm going to type in average, which is actually the name of the function I want, and do open parentheses. When I do open parentheses, that tells it, hey, I'm going to average some numbers, and it's telling me it wants the numbers I want to average. So what I'm going to do is I'm going to left click up here and drag all the way down, and it tells me that I'm going to do H2 up here, H and 2, and I'm going to go all the way through to H10. So it's going to get all of those numbers in between. I'm going to hit close parentheses, hit enter, and there we go. That's my average. Now that I've got that, I simply take that little square on the bottom right and I drag it over. Now I have my averages for all of these. Because each of these is a measurement of an individual note card or individual sets of note cards. Now, some of these are probably a bit heavier than others. Not all of my note cards are made perfectly the same. And so that's why we take so many measurements, because we can have a lot of different types of note cards in there. We want to try and get something that truly represents your average note card. And so we take a bunch of measurements and we average them to actually get those values. Now what we're going to do, most of this ties in with what I did last year, except this time we're going to do something a little bit different. The first thing I'm going to do is I'm going to go through and clean this up a little bit. You can see that I've got, with this one, I've got significant figures that go off to infinity. Basically, I'm quoting and saying exactly how many atoms, and somehow possibly fractions of atoms, make up this particular note card. So I want to clean that up some. I'm going to select all of these here. I click on the first one, hold down Shift, and I click on the other one, and it selects everything in between. I'm going to right-click, and I'm going to go to Format Cells. So I'm going to click that. It'll take it a moment to bring it up. And I'm going right now for the Number tab. You can go through and you can play around with some of the other settings, feel free to, but the number is where I'm going at first. By default it comes up on General, and that just means, hey, you put in the number as the number is. Let's go down to the one that's, interestingly enough, called Number. By default it comes up and says decimal places 2. I can adjust this and bring it down to maybe 0 decimal places, or 1. 2 is actually pretty good for what I'm dealing with, but maybe I get a better scale in the future and I want 3 or 4. But for this I'm going to go with 2. So I select that, and now it makes my data look much prettier. It's almost like rounding it down to the significant figures that you could keep track of and get it pretty precise on. One important note is it's not actually rounding this. It's rounding what we see, but Excel still reads that square as 1.2066666666 forever. Okay? So it's not actually changing the number, it just changes how it looks to us. Now what I'm going to do is I'm going to point out that this is the average for 1 card, this is the average for 10 cards, and this is the average for 20 cards. Because we're going to make a chart out of this. Okay? So I'm going to make a graph or a chart, so I'm going to come up here, there are a couple tabs, I want to go to the Insert tab. And yours may look different, but over here it's going to have charts, and it's going to have a bunch of different options. It's going to have a column one, bar graphs, we're going to have a pie chart. The main one I like to use is usually a series of dots, and it's called an XY scatter plot. So I'm going to select that. I'm going to select the one that just has little dots on it. I'm going to drag this down because it really likes to block what I'm trying to work with. Now Excel tries to think of what you want and fill it in for you. In this case, this is one of the instances where it fails horribly because it does not give me what I want at all. What I'd really like is I'd like to see the mass of the cards here versus the number of cards. Now I can bring up the same old dependent versus independent variable. So my independent variable is how many cards I have. I could choose that, and then however many cards I have is going to have a direct effect on how heavy the result is. So that makes my weight here the dependent variable, and how many cards I have, in fact I'll put that in, number of cards, or hashtag cards, if you will. Thank you, Internet. My number of cards is going to be my independent variable, the one that I can choose, and then my weight is actually going to be my dependent variable, the one that is affected by whatever I choose. So I'm going to come back in here into my chart, and if I click on the data points themselves, the little dots, you'll see that it puts sometimes a little square or little circles on there. I'm going to right click, and I'm going to go to Select Data. And it's got a bunch of weird series, which in this case are just completely wrong. So I'm just going to remove them. And I'm going to add a new series. I want a series name on this, and I'm going to do weight versus number of cards, or hashtag cards. And so this keeps in the same genre, or the same, it's in keeping with what we did in class with the kinematic graphs. I have my Y versus X, my weight versus number of cards. Okay? So I'm going to select now my X values. I said my X values are my independent, and I want that to be my number of cards. So I'm going to highlight my number of cards here, 1, 10, 20. And I'm going to do my Y values, which are my dependent variables. Those are my weights here. So I'm going to select those, and I've got those put in. And I'm going to click OK. because that's what I want. Now I've set up my XY scatter plot where my number of cards, that's my X coordinate, and my average weight is my Y coordinate. I should go in and I should label these graphs that this side is in grams and it's the weight, and that this is the number of cards with no units because it's just a number. It's counting how many cards we have. I guess you could say the units are cards, I guess, but one of the last things that I wanted to show you was how to make a best fit trend line in Excel. Now that we have this nice pretty graph, we can also go in and have Excel generate a best fit line for us. So we'll right click, we're going to go down to add trend line, and it's going to bring up, looks like in this version of Excel it's got it hidden over here, but it should bring up a box where you can select things like exponential, linear, logarithmic, polynomial, etc. For most of the stuff we're going to be dealing with, we're probably going to try and do a linear relationship, so I'm going to leave that on line. I want you to scroll down, this one's important. Down towards the bottom there's an option that says display equation on chart. I want you to select that. And as soon as you do, an equation will actually show up there. Okay? So I'm going to close that. And I like to drag the equation over to the side so I can see it. But there is the equation of my line. This best fit line that it's drawn in here on my data, it has y equals mx plus b. My slope here is my weight versus the number of cards. Basically, it's telling me my actual value that I got from this data of how much one note card is actually going to weigh. In this case, my slope is 1.1448. Taking it to significant figures, I have weight 1 card. I'll bring that over here, spread this out some, and I'll just type that in, 1.14 grams. And if I want to find out now what I think 100 would be, I'm now going to take this, I'm going to do equals this guy times. If you want to do times in Excel, you use the asterisk. It's the little button above the 9 on the number pad, or it's Shift 8 along the top of the keyboard. So that's multiply by 100. So my prediction from my data is that one package of note cards should weigh 114 grams. So we'll pick up with that with another video and see how that compares to our actual results. Although these are the results from last year, so we'll see what we come up with on that. But we're going to go ahead and stop there for now.